Hello friends, today I'm going to explain you about a program called linked list implementation of stack in Q. So at first I'm going to explain you about the linked list implementation of stack, then I'm going to explain you about the linked list implementation of no sorry first I'll explain about the Q and then about the stack linked list implementation. So let's go to the program now. So here at first we are creating a structure here called node. In that we are initializing a variable called info, then pointer variable called link. Then after that we are initializing some variables, some pointer variables, and giving them some null value, that is front is equal to null, then rear is equal to null. Then we are initializing temp pointer variables. Then after that we have created a function here called push function. So here this is in that we are initializing variable data, so we'll push some data into the stack, into the queue. So for at first we are creating a node here, and for that we have given temp is a new node. Then in that node, for that info part we are giving the data, and for the link part we are equating it to null. Then now after that we are giving condition here that if the value of front is equal to null, then front is equal to rear is equal to temp. Else, if the value of rear arrow link is equal to temp, then rear is equal to temp. Pop, that is pop. Now we have initialized another function here, that is pop. In that, if the value of front, we have given a condition here that if the value of front is equal to null, then q is empty. Else, if initializing a variable called data, then temp is equal to front, then in the else part temp is equal to front, then data is equal to front arrow info. So we're copying the data that is in the front arrow info to a variable called data. Then so here the node where so here the value where the front is pointing, we're giving it to we're giving it to temp. Then for that value, for the info value, we're giving it to the variable data. Then the link part we're giving it to the new front. That's why for that we are giving a equation is that front is equal to front arrow link. Now we are deleting that old data by we are deleting the temp, that is the old node. Then we are returning the data. So now here we have created a display function here. So for that initialize a pointer variable monk, then for monk is equal to for front, then while monk is not equal to null, we're displaying each and every value that monk will show until loop goes on. Then we're incrementing here the monk value, so monk is equal to monk arrow link. So after that, for the main function, we are initializing a variable called c. Then we are giving uh, and we are giving it infinite loop here, so that it can ask the program can ask the user about the options that he or she want to choose. Then here we are giving switch case here. In the first case, the push function we have given. Then for the second case, we can pop the elements. Then for the third case, we can display the elements. Then for the fourth case, we can exit from the program. So let us check if the program is running or not. So this is for the queue. We are enqueuing first. That is enqueue the data, then enqueue again, NT, then enqueue again 30. So let us display the data in the queue. So here are the numbers, here are the elements in the queue, 10, 20, and 30. Let us dequeue now. So at first, since this person first out, then that is why 10 is being displayed, then again 10, 30. So let us now the program, since the program is running successfully and the output is verified. Now let's go to the second part of this program, that is the stack implementation of linkers using stack. Again, for that we have created a node, we have created a structure here. Then we have initialized some pointer variables top and temp. for the top we have given the value null. Then again we have given the push function here. In that also we are creating a node first, then for the info part we are giving the data, then for the link part we are giving the top value here, and then top is equal to temp. That means we are giving the top value top to temp here. Then after that we are initializing another function called pop. uh, in that we are giving condition that if top the value of top is equal to null, then stack is empty. Else, in the else part we are initializing a variable called data. Then the top, that means the node that top is pointing, will be given it temp. Then the info that top is having will be given to the variable data. Then the address that the top is having will be given to the new top now. That is the new so a new, the top will be pointing to a new node here. So for then after that we are deleting the old node. Then we are printing out the data. Now here is the display function here. Then for that we have used a pointer variable monk. Then monk is given to top. Then while monk is not equal to null, we are printing out where the loop will go on and on until the monk is not equal to null. Then printing out each value. Then monk is being incremented here. In the main function we have initialized a variable called c. Then we are given a while infinite loop so that the user can program can ask the user about the options functions that he or she wants to choose. Then in the switch case, in first case we are giving push function. For the second case we are giving the pop function. For the third case we are giving the display, and for the fourth case we are given the return, that is the exit. So let us build the program now. uh, so at first we're pushing the data now. Then again we push the data 20, then again 30. So let us display the elements in the stack. So here are the elements in the stack. Since that stack is last in first row, that's why it's showing 30, 20, and 10. Then let us pop each function, each element now. So since the last element is 30, it will be popped out. Then again, then 20, and 10. Now the program is running successfully and the output is verified. Thank you.